ready to look at 3.2, and they're just giving you the formula for the area of the parallelogram. If you ever have to prove an area of a parallelogram, if you previously proved the area of a triangle, you just draw a diagonal from one of the vertices across to the other one, and you get two triangles, and you can prove it that way. Same way with a trapezoid. Notice it's 1/2 of the height and the sum of the bases. And then a regular polygon, notice it's the perimeter, 1/2 of the perimeter times the height, and it's just it has to be a regular polygon, so that means that each one of those sides has to be equal. And then they're going to generalize out to a circle, and that's just the limit as your number of sides goes to infinity. Then there's on 126, there's that summary of the formulas, which I don't think is in that thing I handed to you, but what I want to do is look at problems on page 127. And they say the area of each figure 2A. And you have, that's a equilateral, it's a rhombus. But what happens is when all the sides are equal, those sides are parallel to each other, and then they've given you the height. So it's going to be just 6.2 times 4.3. The area is just the base times the height. And it's 26.66. And it's centimeters squared. The one thing you have to be careful of when you're doing things like that is that your units are the same. You know, later on there'll be problems where the units won't be the same. So the B is the same problem. It's just going to be 10 times the 3 square root of 3 divided by 2. And in an answer, I will take that unless it's specified that you want to have something different, because if you take the square root of 2, multiply it out, you're going to have a rounding error. So, I mean, that's more accurate than taking 30 times the square root of 2. Now, in the answers in the book, they might give you, in like this one.
Why do you take the square root of 3? Yeah, 3.
The height is 3 square root of 2. 42, 43.
So the 6 there is not important?
The 10 is the base. This is the base of that triangle in B, or it's actually a parallelogram. The 10 was this. Then they're showing you perpendicular. But they're saying this is 9 degrees, and they're saying this is 3 square root of 2. So you just multiply this times that. That's what the area of it is. 4. It says complete the following table, which gives the information about a parallelogram with base B, height H, and area A. So the first thing there, they're giving you the base is 13.6 and the area is 74.9. And you're assuming that the units are correct. And so they're wanting to know the height. The formula is base times height equals area. So the height is area over base. 74.9 over 13.6. Okay, 551. And the other one is just a straight formula where it's just base times the height. So the area is going to be 3 square root of 5 times the square root of 5. Square root of 5 times square root of 5 is 5, so it's 3 times 5. That's 15. So 15 is the area. Now 6 is a problem where you have to measure stuff, and I'm not going to do problems like that. Then there's a 8 is a trapezoid. So a trapezoid is two sides are parallel, and they're giving you this. Squeeze myself into the corner there. They're saying this is 90 degrees, and this is 4.5 centimeters. This is 6.4, and it's all centimeters, so 8, and then this down here is 4.8. So the area of a trapezoid is 1/2 of base 1 plus base 2 times the height. Well, the two bases are these two, and the height's this. So it's 6.4 plus 8 times 4.5. So it's like 3.2 plus 4 times 4.5. Can't make it simple enough so I can figure it out in my head. Okay. Does someone have it calculated out? 32.4. Okay. Then 10. So those are pretty straight.
So what was that last answer, please? 32.4?
32.4.
Excellent, thank you.
Okay. So now we're going to do 10. saying this is a right angle, right angle, right to right, 9 meters. So it's a square. I didn't draw it to look like a square. And this distance right in here is 2 meters. Okay, this one's going to take a little more thinking. So, anyone got a strategy?
We have to find the area of the square first.
Okay, and then what?
I don't have any idea of how to find it.
And we want this area right here. Anyone have an idea what the strategy is going to be? The area that's shaded equals, Toby said area of the square, so that'd be right. That'd be where you'd start.
I don't have any clue on how to find the area.
Do you see a trapezoid? Anyone see a trapezoid in there? Yeah, there's a trapezoid. So if you subtract out the area of the trapezoid, then you got it. So the area of the square is going to be 9 squared minus, and the trapezoid's area is 1/2. And what are the two bases? 9 and 2, isn't it? 9 plus 2. See, the trapezoid is this thing right here. And then the height is going to be 9, correct? This is 81 minus 1/2 of 11 times 9. So it's 99 over 2. What's that? 49.5. Does that come up to 31.5 meters squared? So, does that, do you see that? Alright, 12. Says a trapezoid has a height of 5 centimeters, one base that measures 8 centimeters. If the area of the trapezoid is 29 centimeters squared, find the length of the other side.
Professor, what was the last answer? 31.5?
Yep.
Thank you.
Okay. So you're going to substitute into this 1/2 of base 1 plus base 2 times the height equals the area, right? And what we can do is, I like to solve for things. Let's just say this is the one we don't know the value of. So if we got base 1 plus base 2 by itself, we'd have a 2a over h, right? So base 1 would equal 2a over h minus base 2.
So you're just making B1.
I'm just making a literal equation. and then substitute into it. 2, and we know the area is what? 28. We know that the height is 5. We subtract out the other side, other base, excuse me, is 8. Now there's nothing that simplifies in the 2 times 28, so I mean, you're going to have to do the division out on that thing. When you get done with it, it's going to be 3.2 centimeters. I generally like to go out for the literal equation if you can, and then substitute in. Sometimes it's easier, sometimes it's not. All right, 14. This is once again the area of the shaded region. It's not a very good one, but
So
you want the area in here, right? And then they tell us that this side is 5.2 centimeters, and this is 4.4 centimeters. And then they're making from the center here, they're going out. And this is supposed to be perpendicular, it's supposed to be to the center of that thing. And they call this O and this P. And we go out here to Q. And then they're saying OP equals 5.5 centimeters and PQ equals 1 centimeter. So what's the strategy?
big one goes subtract.
Okay. The area of the outside one, and then subtract the area of the inside one. And both formulas are this. The area equals 1/2 the perimeter times the height. And I'm going to call the outside one A1, and then the inside one area 2. So the area we want to calculate is A1 minus A2. So A1 is 1/2. The perimeter is going to be, that's an 8-sided figure, right?
Yes.
8 times 5.2. And then the height is the sum of 5.5 plus 1. .5. And then the inside one is 1/2, and then it's 8 times the 4.4 and then that time the height, and that one is 5.5.
So what does P represent there?
P is perimeter. So it's 4 times 5.2 times 6.5 plus minus 4 times. So when you get through calculating that out, what did you come up with? 38.4 centimeters squared.
How is the perimeter 8?
What's that?
How was the perimeter 8?
Well, there's eight-sided figure, right?
Okay.
There's 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. Each side is 5.2 long. So each side is 5.2, and you take 8 sides. So that's the perimeter. And then there's 8 sides on the inside one that's 4.4 long.
Oh, okay, okay, I see.
And that's the perimeter. Okay.
Okay.
So did you need to look some more?
Okay, I'll just take it.
Got it?
Professor, what was the final answer?
38.4.
38.4?
Is that right?
Yeah? Anyone else come up with a different one? Okay, on this one, they want this area here. And it says find the area of the shaded machine piece shown, which is made by cutting a small semicircle out of a larger semicircle. The radius of the larger semicircle is twice the radius of the smaller semicircle. Okay. Round to the nearest square centimeters. So the
Are we gonna
radius.
use area of the cycle then? Or half of the area
Oh,
of the
dang it.
cycle?
I shouldn't have drawn that line completely. Wonder if I can. I'd have to undo a lot. I probably should. That's a lot. Now it's going to look more like what. So this radius, this distance from here to here is half as long as the distance from here. You know, if it says it's half as long, then this point right here has got to be where that comes down to. There's got to be the outside edge of that inner circle. or that little circle. So that's the relationship you have. If this is R, this is 2R1, then R2 equals 2R1. Okay, that's all they're giving us. No, they're giving us 10.5 centimeters. Giving us this length is 10.5 centimeters. So that's R2, right? So essentially we know R2 and we know R1. And we want to know the area.
Should we convert them to diameters or no? No, never mind, never mind.
You need radiuses for areas. Well, we want to know the area of the shaded region. And it has to be the area of the larger circle, larger half circle, minus the area of the 1/2 smaller circle. Well, the area of a circle is what? Pi r squared.
Yes.
So this one, if we did 1/2 of pi, and the r there is what? 10.5, and we square it, minus, if we do 1/2 of pi, and then it's 10 over 5/2, that's the radius squared. That should be it, shouldn't it? Anyways, problem is problem 16. Is that right? And so if we calculate that thing out, then it should be approximately equal to 130 centimeters squared. It's actually 129.89. Is that what you got? Okay, 18. Says determine the area of the shaded region in each.
What was the answer?
What?
What was the answer?
Approximately 130. It's actually 129.89.
That would make sense.
Okay. I'm trying to make my circle first. This is, I probably should have made my square first. That's not too odd. Anyway, that's actually a square, isn't it?
Yes.
And if we do the radius, this is 5 inches. 5 inches. And then we want to calculate the area right out here, right? So what are we going to do?
So the area of the square is okay.
So the area would equal area of the square minus the area of the circle, right? And the square is going to be what? 10 squared? 10 squared. Because it's, half of it's, length is 5. So. And then minus pi r squared is the circle, and that's 5 squared, right? And that's going to be 2146.
Is that by r squared?
5 squared. Okay.